my name is Pranavi. My roll number is 45. I am from CIC section. Lasers. Laser. It is an abbreviation that is light amplification by stimulated emission of radiation. Laser. Laser light is highly powerful and it is capable of propagating over the long distances. It is a coherent light. It has high intensity, high amplitude, high directionality, that is unidirectional, and high monochromaticity. And it has low angular speed. These are the properties of laser light. Introduction. Before the laser, the measure is invented by the Towner in the year 1939. The stimulated emission, which was invented by the Einstein in the year 1917. Later, different types of lasers like ruby laser, helium neon laser, diode lasers are also invented. Next, absorption. Generally, the electrons are present in ground state only. When we supply an external energy to the electron which is present in the ground state, it moves from lower energy level to higher energy level. This is said to be absorption. Here, E1 is the ground state lower energy level, E2 is the excited state higher energy level, and the energy which is supplied to the electron, that is photon energy, equal to h nu. The rate of absorption, it depends on number of atoms N1 present in E1 and density of radiation U of F. So, P12 is directly proportional to N1 into U of F, whereas P12 equal to B12 into N1 into U of F, where B12 equal to the Einstein coefficient by stimulated absorption. Next, spontaneous emission. It is based on lifetime only. The lifetime of the ground state is infinity and the lifetime of the excited state is 10 power minus 8 seconds. As the electron stays in excited state up to 10 power minus 8 seconds, later it comes back to the lower energy level by emitting the photon. The emitted photon energy E equal to h nu, whereas E1 is the ground state, E2 equal to the excited state. The number of atoms present in the excited state is N2 and number of atoms present in the ground state is N1. This transition depends on atoms in excited state N2, whereas P21 is directly proportional to N2. From this, P21 equal to A21 into N2, where A21 equal to the Einstein coefficient for the spontaneous emission. Here we get incoherent radiation by spontaneous emission. Next, stimulated emission. When we supply an external energy to the electron which is present in excited state, it moves from higher energy level to lower energy level by emitting two photons of energy, that is 2hf equal to E1 minus E2. This is called as stimulated emission. And this emission is depends on energy density U of F and number of atoms present in the excited state, that is N2. P21 is directly proportional to U of F into N2, where P21 equal to B21 into N2 into U of F. Here the B21 equal to the Einstein coefficient for the stimulated emission. We get coherent light by stimulated emission. Population inversion. It is the process of increasing the excited electrons in higher energy levels. Generally, the electrons which are present in the ground state are more when compared to the electrons present in the excited state. When we supply an external energy to the electrons which are present in the ground state, it moves from lower energy level to higher energy level. At this time, the electrons present in the excited state are more when compared to the electrons present in the ground state. This is said to be population inversion. Later, Einstein relation. Relation between the Einstein's A and the B coefficient. A for the spontaneous emission and B for the stimulated absorption and stimulated emission. In equilibrium equilibrium absorption rates and emission rates must be same, that is B1 to N1 U of F equal to A21 into N2 plus B21 into N2 into U of F, whereas A21 into N2 equal to U of F into B1 to N1 minus B21 into N2. So U of F is equal to A21 N2 whole divided by B1 to N1 minus B21 N2. That is considered as first equation. U of F is equal to A21 whole divided by B21 whole divided by B1 to N1 whole divided by B21 into N2 minus 1. This is considered as second equation. We know the Boltzmann distribution law. Ni equal to N0 into e power minus Ei whole divided by Kt. From this, N1 is equal to N0 into e power minus E1 by Kt, whereas N2 is equal to N0 into e power minus E2 whole divided by Kt. N1 by N2 equal to e power E2 minus E1 whole divided by Kt. We know that E2 minus E1 is equal to Hf. Substitute E2 minus E1 in the equation 4. We get N1 by N2 is equal to e power Hf by Kt. Substitute N1 by N2 in the equation 2. We get U of F is equal to A21 whole divided by B21 whole divided by B12 whole divided by B21 into e power Hf by Kt minus 1. This is considered as seventh equation. According to Planck's radiation formula, U of F is equal to 8 pi Hf cube whole divided by C cube into 1 whole divided by e power Hf by Kt minus 1. This is eighth equation, where B12 equal to B21 and A21 whole divided by B21 equal to 8 pi Hf cube whole divided by C cube. So, the ratio of spontaneous to the stimulated emission is R equal to N2 A21 whole divided by N2 B21 into U of F. Cancel N2 and N2 on numerator and denominator. We get A21 whole divided by B21 into U of F, that is 8 pi Hf cube whole divided by C cube into U of F. Let us consider it as 10th equation. So, U of F is equal to 8 pi Hf cube whole divided by C cube into R, and U of F is equal to 8 pi Hf cube whole divided by C cube into 1 divided by e power Hf by Kt minus 1. By comparing 11th and 12th equation, R equal to e power Hf by Kt minus 1. If Hf is less than Kt in thermal equilibrium, then R equal to e power Hf by Kt minus 1 less than 1. If Hf is less than Kt, that is stimulated emission, it is valid in the microwave region, that is measure. Whereas Hf is greater than Kt, that is spontaneous emission, it is valid in the visible region, that is incoherent light. Next, optical pumping. There are a number of techniques for pumping a collection of atoms to an inverted state, that is optical pumping, electrical discharge, direct conversion. First, this optical pumping is used in the solid laser, that is ruby laser. When a photon of blue-green light incident on the ruby crystal, the electrons from the ground state absorbs and excited and jumps on the higher energy state levels and come back to the metastable state. They increase the population of electrons in the metastable state. This process is called optical pumping, which was done by the flash tube. Types of lasers. There are three types of lasers: solid laser, liquid laser, gaseous laser. Solid laser is ruby laser and gaseous lasers are helium neon laser and CO2 laser. Ruby laser. To produce the laser from the solid, ruby crystal is used. It was the first type of laser invented, and it was first operated by the T.H. Maimon in the year 1960. The operators of the ruby laser are ruby rod, that is a cylindrical rod. In this cylindrical rod, a rectangle shaped rod is present. Next, flash tube, which is made up of xenon, and also we have the electrodes. And these are the operators of the ruby laser. First, actomedium. The active medium, that is in rectangular shaped rod, a mixture of Al2O3 and Cr2O3 is present. The ratio of Al2O3 and Cr2O3 is 99.95% plus 0.05%. This rectangular shaped rod is silvered on both sides. One side is totally silvered and other side is partially silvered. Next, and flash tube is surrounded around the ruby rod, and this flash tube is switched on to the power supply, that means connected to the power supply also. When we instant a beam to the ruby rod, due to the multiple reflections between the total reflecting mirror and the partially reflecting mirror, we get the laser light, that is discontinuous output, that is a pulsed laser with a wavelength of 6943 Armstrong units. This is the construction of a ruby laser. Next, this is the energy level diagram of the ruby laser. It is a 3-level energy diagram. One is ground state, another one is excited state, and another one is metastable state, that is the state between the ground state and the excited state. Next, applications of ruby laser. They are still used in a number of applications where short pulses of red light are required. The holographies around the world, they produce the holographic portraits with ruby lasers. And many non-destructive testing labs, they use the ruby lasers to create the holograms of large objects such as aircrafts to look for weaknesses in the lining. And these ruby lasers are also used in the tattoos and hair removal. These are some of the applications of ruby laser. Drawbacks of ruby laser. The laser, it requires high pumping power because the laser transition terminates at the ground state and more than half of the ground state atoms must be pumped to the higher state to achieve population inversion. And the efficiency of the ruby laser is very low because only the green component of the pumping light is used while the rest of the components are left. And this laser output is discontinuous output, and the defects due to the crystalline imperfections, they are also present in this laser. To overcome these drawbacks, a new laser is invented, that is helium neon laser, that is a gaseous laser. And this helium neon laser have many industrial and scientific uses, and they are also often used in the laboratory demonstration of optics. This is the diagram of the helium neon laser. In this also we have three parts: active medium, pumping source, and optical resonators. The active medium, that is a glass discharge tube which is made of quartz. In that discharge tube, the helium and the neon gas are filled. The ratio of the helium and the neon gas are 10:1. Here, the pumping source is electrical discharge. That means the electrodes are present around the discharge tube. Later, the optical resonators are two optical resonators, that is totally reflecting mirror and the partially reflecting mirror. These both are silvered at the quartz tube. One side is totally silvered and other side is partially silvered. And we get the output through partially reflecting mirror only, that is a red laser beam with a wavelength of 6328 Armstrong units. And these have a long operating life of the order of 50,000 hours. This is about the gaseous laser, that is helium neon laser. Next, this helium neon laser has a 4-level energy system. That is, during the excitation process, the helium gas is used Whereas the neon is stable, after exciting the helium gas, it transfers its energy to the neon, and at de-excitation stage, the neon gas is used. Here, both components are used when compared to ruby laser. So, the efficiency of this gaseous laser is very high. This is the energy level diagram of the gaseous laser. Next, applications of helium and neon laser. The narrow red beam of the helium neon laser is used in the supermarkets to read the barcodes, and it is also used in the hologram, producing the 3D images of objects. And these helium neon lasers have many industrial and scientific uses. These are some of the applications of the helium neon laser. Next, applications of laser. The laser beam is used to measure the distances of sun, moon, stars, and satellites very accurately. It can be used for measuring the velocity of light, to study the spectrum of matters, that is, to study the Raman effect also. It can be used for increasing the speed and the efficiency of a computer for welding purpose and biomedical science, and it is also used in 3D photography also. The applications of lasers, there are huge applications. It is used for the communication, TV transmission, to search the objects under sea, and it can be used to predict the earthquake. And these laser tools are used in surgery, and it is also used for the detection and treatment of cancer, and it is used for the construction of dams and for holography, fiber optic communication, and it is also used in the military, and it is used to accelerate some chemical reactions. These are the applications of laser in day-to-day life. From this, we can conclude that the lasers are very important in our day life. So, the laser technology is widely used in future also. Next, holography. Holography. What is this holography? Holography, it is obtained from the Greek. Holo means whole and graphy means write. That means a complete recording of an image. It is an advanced form of photography that allows an image to be recorded in 3 dimensions. The holography is a method of producing a visual 3 dimensional image of an object by means of light wave patterns recorded on a photographic plate. The 3 dimensions are height, width, and depth, and it is known as the lensless photography and screenless photography also. It produces the lifelike images. The Dennis Gauber is the father of holography, and he received the Nobel Prize in the year 1971. Working of holography. Laser light. Usually the helium neon laser is used because it gives a continuous output. Beam splitter. A device that uses the mirrors and the prisms to split the laser beam into 2 beams. One is object beam and other one is reference beam. Mirrors. They direct the beams of light to correct locations. Holographic film. To record the image very high resolution, and it can be seen through naked eye. The image floats in the free space like virtual image. How to create a hologram? To create a hologram, laser light, that is coherent light, is split into 2 beams, reference beam and object beam. The reference beam, it stays undisturbed. This object beam, it strikes on the object and then bounces onto the holographic plate. The working of holography is divided into 2 phases. One is recording and another one is reconstruction. First, recording. In recording, we use laser beam, that is coherent light, beam splitter, mirror, photographic plate, and one object. This is the Arrangement of recording a hologram. Recording a hologram. When a coherent light is incident on the beam splitter, it split the beams in laser beam into two beams. One is illumination beam and another one is reference beam. This illumination beam, it strikes on the object and then bounces onto the photographic plate, whereas the reference beam, it directly strikes onto the photographic plate. Here the interference is used, that is superimposition of the reference beam and the object beam. It gives a interference wave patterns by creating a hologram. This is an optical arrangement of recording a hologram. Reconstruction. As this hologram can be breaks into more pieces, hence we can reconstruct this hologram through this process. This is the reconstruction beam, that is a laser beam. When a hologram is later illuminated with coherent light of the same frequency that created, a three-dimensional image of the object appears, that is virtual image. This is the image, and this is about the reconstruction of a hologram. Later, photography versus holography. What is the main difference between a photography and the holography? In photography, 2D recording process. In holography, 3D recording process. Ordinary light can be used, but in holography, laser light is used, that is coherent light. In photography, it is a lens system. Holography, it is lensless system. Photography, it is a screen system. Holography is a screenless system. The image has poor resolution in photography. In holography, it has very high resolution. It gives a virtual image. That is the difference between a photography and holography. Next, advantages. Cost effective, higher storage capacity, increased feasibility of objects, enables the achievement of multiple image on a single plate and give 3D images, ability to combine with other technologies. These are some of the advantages of holography. Disadvantages: they provide the static images and they do not produce the images of the complex movement. They require the complicated precise machinery to produce and view an image. And also the reference illumination beams are collinear. These are some of the disadvantages of the holography. Next, applications of holography. This holography is used in optical computers, biomedical applications, compact disc, grocery store, holographic interferometry, holographic scanners, holostores. First, optical computers. These optical computers will use the holograms as circuit elements. Parallel processing is made possible because when a hologram is addressed, all the information comes out simultaneously. Biomedical applications. The biomedical applications of the holography is actively pursued in the US and Europe. The holograms are made inside the live organs through optical fibers and providing the more details than any previous alternate techniques. Compact disc. The compact disc players, they use the holograms to handle the light. And the grocery store. In grocery store, scanners use the spinning holograms. Holographic interferometry. It is used in the numerous laboratories for non-destructive testing. It visually reveals the structural faults without damaging the specimen. Next, holographic scanners. These are used in store. Check out the counters for reading the barcodes, and a rotating computer generated hologram is responsible for both scanning and detecting of the scattered light. Holostore. It is a holographic computer memory system. It being manufactured to replace your disk drive. It will have 1000 times more memory capacity and no mechanical movements. In video game living room also this holography applications are used, and in teaching and education, and in another applications also this holography technology is used. This holographic technology has endless applications as far as the human mind can imagine. These holographic technologies, they are not just used for art and business communication, and they are used for safety, security, education, planning, and the strength of our civilization here. This holographic technology will become a very integral part of human societies and civilizations in future. Thank you, ma'am. Thank you for giving me this opportunity.